start recording. There we go. Okay. So what we're going to do is we're going to look at some half reactions in isolation and practice balancing them with the rules that we're going to learn. And then we'll look at taking a full reaction, splitting it apart, balancing them, and then putting it back together. Okay? But for now, just isolated half reactions, and these are the steps. Balance all the elements except H and O. And you're going to do that just like you do with any other reaction you are going to use. How do you normally balance something? You add. How do you balance a reaction? You add coefficients. So we're going to balance all the elements except H and O using coefficients. Now there's a little mnemonic device that Hebden has come up with, so I've stolen it. He calls these the major atoms. So anything that's not hydrogen or oxygen, he calls it the major atoms. Second thing you're going to do is you're going to balance the oxygen atoms simply by adding water molecules to whichever side does not have enough oxygen. Third thing you're going to do, you're going to balance hydrogen, because if it wasn't out of whack already, you've probably put it out of whack by adding water molecules. You're going to balance hydrogen by adding H+ ions. And then finally, if you remember, reactions don't have to be balanced only in atoms, but also in charge. So this final step is where we balance the charge. And we do that by adding electrons, just like we did in our example last week. Okay, and the little mnemonic device is that major hydroxide says charge. Yes? You got it? Okay, cool. So if you follow these steps, your equation will now be balanced in acidic or neutral conditions. If you need it to be in basic conditions, like let's say it says, this takes place in a solution of NaOH. If it takes place in basic conditions like that, there are 3 additional steps that you're going to forget by the time we get to it, because it'll be example 3 by the time we get to it. To balance in basic conditions, you say, I'm always going to have some, or at least I'll most of the time have some hydrogen ions because I put them in there, yes? How can I get rid of hydrogen ions? What gets rid of hydrogen? Hydroxide. So I'm just going to neutralize the hydrogens with hydroxides. Yes? So I'm going to say, oh, in my products, I have 3 hydrogen ions. So I'm going to add, actually in my products, I'm going to add 3 hydroxide ions, and that's going to make 3 waters. Okay? But what I do to one side of an equation to keep it equal, what do I have to do? Same thing to the opposite side. So if I have 3 hydrogens here, I add 3 hydroxides here to neutralize it, but I also add 3 hydroxides to the other side to keep it balanced. Okay? And then you take those, and once you've added it, you make the water by combining the H and OH. And then you're going to find that sometimes you have things on one side that will cancel with things on another side, and you will just cancel anything. Okay? But right now, we're going to focus on the first 4 steps. Major hydroxide says charge. Okay. Now, do you have blank here?
Yeah.
Good. Oh, yes. Okay. All right. So we have Mn3 plus goes to MnO4 minus. So our first step is to balance the major atoms, which is atoms that are non-what? Non-oxygen, non-hydrogen. Who is the only one here that is non-oxygen, non-hydrogen? Mn. Is it balanced? Yes. So, oh look, step number 1 is done. Okay. What is step number 2? Balance O by adding what? Water, H2O. Oh, why did I put a check mark there? We haven't done it yet. All right, so on my right-hand side, how many oxygens do I have? 4. On my left-hand side, I have 0. So what I'm going to do is I'm going to say I need 4 waters here, plus Mn, 3 plus, goes to MnO4 minus. And I would say when you're starting out balancing half reactions, I would write a new line for every step. Yeah? When you get good at it, you can do it all in one line without writing out each step. But I would say starting out, try writing it each step so you can keep track of what you've done to see if you've made a mistake somewhere. Okay? My answer key shows all the steps. So if you make a mistake, you can see where the mistake has been made. What is step 3? We're going to balance H by adding H plus. Okay. How many hydrogens on the left? 8 hydrogens on the left. Are there any hydrogens on the right? No, so we need to add 8 hydrogens to the right. So we're going to have 4 H2O plus Mn3 plus goes to MnO4 minus plus 8 H plus. Step number 1, major. Step number 2, oxygen, balanced by using water. Step number 3, hydrogen, balanced by using H plus. And what is step number 4? Balance the charge by adding what? Electrons. Okay, so please tell your partner what the charge is on each side of this reaction.
So I would say
what's the charge on the left-hand side?
plus 3.
Plus 3. So I like keeping track of that in like a little circle. Okay, and what is my charge on the right-hand side? If you have any sort of trouble figuring it out, just go, okay, I got one of these, so I have -1. And I also have 8 positive things, so I have +8. And that gives me a total of +7. Okay, you don't have to write out that work if you can just see it in your head, but sometimes it's helpful. Will we add electrons to the side with a higher positive charge or a lower positive charge? Higher positive charge. So we're going to have 4 H2O plus Mn3 plus goes to MnO4 minus plus 8 H plus how many electrons? Tell your partner. 4. 4 electrons, because if we add -4 now, we will get +3. Yes?
So why would more electrons come from the lower core of the hydrogen than you end up with 4 H plus and 4 H?
Because the electrons are going to the other substance in the other half reaction.
All right.
Yes? Okay. So after balancing, I would like you to tell me if this is an oxidation or a reduction. And I would like you to explain to your partner 2 ways that you know why.
Oh, yeah. Oh, it's lost. No, it's right here. Off the item. But also, are you Leo? I'm Leo.
First of all, oxidation or reduction? Oxidation. Okay. Now, why is it oxidation, Rigel?
That's because oxidation number is +3, so the size.
Mm-hmm.
So the oxidation number is
Yeah, you can look at your oxidation number. It is +3 in the reactants. Now, if you are good at doing these things in your head, you can say I have 4 times -2 is -8, but one of those is left over, so I need a +7. But if you're not good at doing that in your head, because sometimes I'm not good at doing that in my head, make sure you write out MnO4 minus, you have 1 Mn, you have 4 oxygen, and what's your overall charge? -1. So we're looking for our 1 Mn. We know that the oxidation number of oxygen is -2. So Mn minus 8 equals -1. So Mn has an oxidation number of +7. Like I said, if you can do that in your head, more power to you, but sometimes it's nice to write it out so you don't make silly mistakes. So method number 1 of knowing that it was oxidation, our oxidation number has increased therefore, this was oxidation. Method 2. Oh, sorry, what was that? Electrons are lost. They are coming out of the half reaction. I have one more question for you. Is Mn3 plus an oxidizing agent? Or a reducing agent? Chat with your partner about that one. Make sure you feel good about it. We're going to make other people do some work today. Yeah. What do casting agents do? Do they cast other people or do they get cast by other people? They cast other people. So what do oxidizing agents do to the other guy? They oxidize the other species. So if they are oxidizing the other guy, which is the reducing agent, what's happening? What are they doing to the reducing agent? No, they're oxidizing the other guy, but what's physically happening when they oxidize the other guy? If the reducing agent has to be the reducing agent has to be losing electrons, right? Because it is being oxidized. So what's happening to the oxidizing agent then? If it's causing the other guy to lose electrons, what must it be doing? Therefore, oxidizing agents get reduced. So the oxidizing agent gets reduced. The reducing agent gets oxidized. So we agreed that our half reaction was an oxidation. So if Mn3 plus, where did it go? Mn3 plus got oxidized. Oh my gosh, this is the other way you can tell something's been oxidized. Look, it ain't got no oxygens. Now it has a whole bunch of oxygens. It has been oxidized. Yes? Now you got to be careful if you've got like a 2-to-1 ratio or something like that, because if you have NO2 goes to N2O4, have you actually added N's or O's to the N? No, you have the same ratio, right? So you have to watch out for that. But if you're just looking at something really straightforward like Mn, and now it's all of a sudden got a lot of oxygens on it, that was oxidation. And if you're looking at something that has oxygens taken off of it, that would be reduction. Yes? Now, if Mn got oxidized, therefore it must be the what kind of agent? Be the reducing agent. And if you're not feeling awesome about that, make sure you do 6.1c and go hang out with Tyler, because Tyler does a beautiful job explaining. At least I think he does. You might disagree with me, I don't know. So literally balancing half reactions. If you remember those 4 rules, you can do all the acidic and neutral reactions. Shall we try one more? Do you want to try one on your own?
Yeah.
Try the next one on your own. Major hydroxide says charge. Major OH, charge.
Oh. Oh, yeah. Wait, unless you get like acid, it's fine. Hold on.
Did you get 6 water, 1 I2 on the reactants? And in the products, 2 IO3, don't forget to write the minus. I always drop my charges along the way somewhere because I'm messy that way. 12 H plus and 10 electrons.
Yes.
Yes. Oxidation or reduction? Oxidation because the electrons are coming out. Oh, look at that. If electrons come out, which starts with an O, that is oxidation. Yes? I2, is it an oxidizing agent or is it a reducing agent? It got oxidized, therefore it is a reducing agent. All right. We already did this. Now we're going to balance it in base. I've given you the structure. This is balanced in acid. Do you remember what we do to balance it in base? This is step 5. See, I told you by the time we got here, you'd forget. We need to make it basic. So what do we need to do with our hydrogens? We need to neutralize the hydrogens by adding OH minus. So over on this side, we're going to add 12 hydroxides. But what we do to one side in order to keep it balanced, what must we do to the other side? Plus 12 hydroxide. And now we're going to add this up, but when we add it up, we're going to take our 12 hydrogen and our 12 hydroxide. Okay, so neutralize hydrogen by adding OH to both sides. What are we going to get from our 12 hydrogen and our 12 hydroxides? We're going to get 12H2O. So when we add it, we don't just write 12H and 12OH, we write 12H2O, and everything else just stays the same. But of course, on the reactants, we will have 6 water plus I2, and we will also have those 12 OH minus. Yes. That would be your canceling, and you can actually do it before you finish adding, or you can do it after you finish adding. So if you look at it and you're like, I'm getting 12H2O and I got 6H2O, and you just want to slam right into 6H2O in the products, that's fine. I just wanted to show it so you know what's going on. We have 6 water over on the left. We have 12 water over on the right. So we can cancel 6 water and we'll be left with 6 water. I would then probably rewrite it so it's tidy. Your homework is to study for your test. Thank you. Yes. No.